All right, all systems are green. That means we're go. Hello, everyone, and welcome to the official quarantine version of the HamptonRoads.net users group. It's April 14th, 2020. Thank you to Paul Shin Jr. for cheering one bit on Twitch. And if you're watching this afterwards on YouTube or something, we were live on Zoom and Twitch. And so we were supposed to have a real life meeting, and we were going to have a great speaker from Northern Virginia come actually drive down and speak at a physical location to people in a place. But that's not a thing anymore, talking, meeting with people, being places. So we have turned to virtual, and I needed someone I could trust to come in and do an amazing job, and Mr. Matthew Groves raised his hand and said, I could do that. So we are very glad to have you, Matt. We have no giveaways this month. Next month, we might have some giveaways for everyone who showed up to the live meeting. So more on that next month, because we'll probably be doing virtual for at least another month or two. We'll see. Fingers crossed that all this COVID stuff goes away. Well, with that, Matthew, I'm just going to turn it over to you and let you start talking. I will monitor the chat on both Zoom and on Twitch, and if something pops up, I'll interrupt you when you're taking questions.
That sounds fine to me, Kevin. Thank you very much. It's always been a goal of mine to eventually get to the Hampton Roads user group, and I've always kind of wished I could make it there. For whatever reason, travel's never worked out. So I guess be careful what you wish for, because now I get to present at the Hampton Roads user group. But I wish there were better circumstances. But thank you, everybody, for showing up here today. And we're going to talk about microservices, and specifically not about just what a microservice is. It's not like an intro level type of thing, but we're going to talk about how to make your microservices more resilient, try to make them as bulletproof as possible. And so let's get into it. This is, I think, where we should start. This is a good place to start, is that microservices really are kind of a curse. And no one really wants them. Microservices are a distributed system, and distributed systems bring a lot of challenges with them. So no one in their right mind really wants to deal with microservices. Monoliths are so much simpler to develop. It's a single application containing all the features. So if I'm in the payment part of the system, then I need to access something about a user. That's just a method call. It's really easy. But in a microservice system, it's a method. It's kind of like a method call over HTTP, over a network. So I have to call the user system, and there's a chance the user system's down. It's not easy to refactor. If I add a new field to the user service, I can't just go and update all the other services. Some other team might be responsible for the payment service, so I can't go and make that change all the way across the enterprise, at least not at the same time. And transactions can be a problem. How can I guarantee that an update gets applied atomically to two different services? That's a challenge. It's possible, it's challenging. And it's more expensive to develop. If you're a small team and you don't need a lot of scale, I would say stick with a monolith or start with a monolith. But if you're a larger company like Netflix or Disney or American Express, scale is a problem, and microservices might help you. Because microservices, fundamentally, the reason for them is that you can independently deploy and scale parts of your system. So if you are in a situation where you have the user system and a payment system, and your payment system's used, it's used a decent clip, but the user system is used a lot. We can scale up just the user system. With a monolith, we have to scale the entire thing together. So with a microservice, we can scale individual parts. And that's kind of the benefit to microservices. But it comes with a lot of challenges. So we're going to talk about those challenges and how to deal with them today. So I'm at the HamptonRoads.net user group. This is the well, I probably should put a more general link on there. But anyway, if you're in the Hampton Roads area, or if they're doing virtual sessions next month as well, definitely check it out. I've known Kevin Griffin for a long time. We're fellow MVPs, and I've always had my eye on the Hampton Roads.net group, and they do some cool stuff there. So thank you very much for having me. And that's the cool looking logo I grabbed from your site there. My name is Matthew Groves. I'm a developer advocate for Couchbase. These are the different ways you can contact me on Twitter. I do some live coding on Twitch. We were just talking about this before we started, but I do a lot of that these days. I do less of the podcasting and blog these days, but I still have lots of stuff out there. You can find crosscuttingconcerns.com. You can contact me there. And I'm not an expert, just to say that up front, on microservices or anything really. I'm more of an enthusiast. I'm very excited about different types of technologies, and I try to learn as much as I can about them, and then I try to share as much as I can about them in presentations like this. So let's get down to it. Autonomous microservices. I want to introduce this term, if you've not heard this before, of a microlith. And so some companies, some projects, they want to migrate from a monolith to microservices, hopefully for a good reason. Like I mentioned, the scaling is a good reason. So some organizational benefits, perhaps, things like that. But what you might see when you start out is you're going to start developing a microservice or a system of microservices and treat them as a monolith. So what you end up with is the worst of both worlds. You get all the problems you had before, but now they're distributed. So microservices make up a system. This may be a dozen services or whatever, but they all act within the same system. And unlike a monolith, they need to be autonomous. So if you're relying on synchronous calls, you're going to have trouble because the network is a whole new problem introduced into your system. If the service is offline, you can't get user data. So think about microservices as if they were human beings. You know, we rely on each other. Well, we used to rely on each other to commute to work, for instance. We used to have these things called buses, and you could get on the buses and you go someplace and you have a bus driver, someone who's controlling the bus. But we don't need the bus driver all day long, right? Just during our commute. We don't have to have him come with us to accomplish my job, right? We just need him at a certain period of time. So I'm autonomous, the bus driver is autonomous, but we both rely on each other at some level. And so that's how I want you to think about microservices, just think of them as human beings. And they're able to cope on their own, they are autonomous, and your service should do the same. So what does it mean to be an autonomous microservice? And I'm going to say it has 4 characteristics. And so the first one is that it scales easily. And we're kind of starting there. We're saying, okay, the purpose of a microservice system in the first place is to improve scaling and flexibility when it comes to scaling. We can have certain parts of that system scale independently. These other things don't necessarily come with that out of the box. So we're going to cover each of these different features as we go through this presentation. So just slicing up a monolith does not give you those things just inherently. All right, so we have to make sure we take care of those things. So let's talk about isolated failure. And this is the first important thing to make your microservices as bulletproof as possible. So just imagine a microservices architecture. It might look something like this. All these different services, and they all rely on each other to some extent, maybe some directly, maybe some indirectly. But let's say the user service goes down for whatever reason. There's a crash, a bug, someone tripped over a network cable, whatever. In this scenario, the whole system goes down because every other one of these services depends on the user service, again, either directly or indirectly. So it becomes like a single point of failure. So we need to do something to isolate this failure. If this user service goes offline, the other services still need to keep going. So how can we do that? One of the ways we can do that is we can cache the data we need instead of asking for it. So we're going to add caching to the different services. So let's just say that, let's look at like a slice of that system. We have an order service, a delivery service, and payment service, and they all depend on the user service to get information about user. But say the user service goes offline. I'd like the order service, delivery service, and payment service to keep going. So set up some sort of asynchronous communication. Whenever a user is updated in the user service, it's going to have to trigger some event, and the other services can subscribe to it. And then those services can then store the data that they need locally. Not necessarily the entire user data, just the parts they need. So the order service may need some information from like the user's name or the user's ID or something like that. The delivery service may need the address. The payment service needs payment information, but they don't all need the entire picture of the user. So they can just cache the part that they need. And so something like RabbitMQ or Kafka could do the job here. Whenever a user service change happens, it publishes an event to RabbitMQ or Kafka stream or whatever, and then those other services can subscribe to that and save that data. Now, skipped ahead there a little bit, sorry. So those services will store the data they need locally, not necessarily the entire data, but they can still go to the user service if you want them to directly, but they can fall back to the cache. And so if you're caching data, this gives you a window of time to get that user service fixed, for instance. And now one of the challenges here is there could be some eventual consistency problems, right? The cache might be out of date for a short period of time, right? It's not synchronous. But let's, again, think back to the metaphor of humans. Real life is not strongly consistent. You know, if I change my address, if I move to a new house, I fill out a change of address card. It might not get entered in the post office system for hours, for days, for weeks, for all we know. In the meantime, stuff's going to get sent to my old address. So as an autonomous person, I have to figure out a way to, okay, well, I've got to go and check my old mailbox for a while, or give my apartment complex a forwarding address, or something along those lines. I've got to figure out. Or maybe I do the change of address earlier, and then I start forwarding the mail on. I get ahead of it. So some things I can do to compensate for that. So we have to start thinking about compensating for the asynchronous differences here. Because again, we don't want one service going down to blow up the whole system. So there's other types of communication. So I mentioned synchronous can be problematic, but as devs, we generally think of synchronous communication, especially if we're coming from monolith. That's changing, I guess, a lot. Maybe this is out of date for me to say this, but most problems can be reframed to being asynchronous. .NET specifically has really made a push towards async and await, and to just kind of make you think about method calls differently. Now, I'm not necessarily referring to async and await within a program, but asynchronous communication between services. Streaming is another approach, so I haven't seen that much, but that's something that may be becoming more and more common. So async should be the norm between services. So I always like to use Amazon as an example, right? You place an order and you get a confirmation email almost right away. It kind of seems like it's synchronous, but it's really not, right? So there's going to be an inventory service that may be invoked, a delivery service, a payment service, and all those things happen asynchronously. You don't sit there on the web page after you hit the buy button and wait for them to check that your address is correct and your payment service is, you have sufficient funds, all that kind of stuff. It all happens asynchronously. So even if the payment service is offline temporarily, you can still place the order. It's just that the payment will be checked later. And you make it an email that says, oh, your card was declined. Sorry, we couldn't finish your order. And it's all going to get queued up. And then once the payment service is back online, it goes to work processing those payments. So think of it like that. We have to introduce some extra systems for that, extra complexity to deal with that. Okay, so if we take those steps, we can achieve some better isolation of failure. So caching is one, and asynchronous communication is the other. And they kind of go hand in hand a little bit. So you can tolerate some failure, maybe for minutes, maybe for hours, maybe even a day or more. So we can start to improve that. But our microservices themselves are not yet resilient. So I forgot about this, but I do want to pause for a second, see if any questions have come in on Zoom or on Twitch before we go on to the next one, which is resilient. So anything to report, Kevin?
So far, nothing.
No questions so far. Okay.
Nope.
Good. All right. And I'll try to remember to do that again at the next break. But now I want to talk about making your services resilient. And what this boils down to is don't let any other service break your internal state. Now, one of the ways to achieve this is with a pattern called event sourcing, or you might think of it as logging. So it's a way to build up the history of the state of some entity. So then you can rebuild the current state using that history, kind of like an accounting ledger. You know, we'd like to think of our bank accounts as, oh, my balance is $200. But really what you have is a complicated history of debits and credits that all combine together to get to that current balance of $200. So let's talk about this from a microservices point of view. So let's say some other team or some other service pushes an update, and that update causes some inconsistencies in the service or the data. So there's a bug perhaps, and they start producing data that's wrong. And that sends a message to my service. So my service gets that data, and now I'm storing some of that data in my service. Then maybe that causes me to then produce some inconsistent data that goes out to another service. So at this point now, one service is started pushing out incorrect data, and now it's been distributed all over the place, kind of like a virus spreading through people, right? That's maybe a tasteless metaphor to make right now, but that's kind of what we'd see there. So we have a distributed bug. So what's the source of that bug? How do we get to the root of that and debug it? So event sourcing allows us to go through the history and track the changes in my service. So I can see when the inconsistency was generated, and I can maybe add an offsetting record to fix it, like a correction in the ledger, or I can completely reset the state and reprocess from some starting point. So this is a pattern I definitely suggest using, and this is useful not just in microservices, but it definitely helps with microservice systems. There's a blog post here at the bottom, a link to that. I can give you the slides later if you want to, Kevin. You can share them however you like to. But that's a link there. A colleague of mine wrote that about the event sourcing and event logging pattern, it's important for thinking about using that for microservices.
We do have a question.
Oh, sorry, go ahead. Yeah.
All right, let's see. Matt, you can also see this in the QA panel. Okay. Does traditional caching, memcache or caching in .NET, does it always refer to a cache? Or if I have an order service and a payment service, if they have their own internal database, is that considered a cache as well?
I mean, that's really a decision you'd have to make, right? So the deal with memcache is that it's really specifically a tool meant for performance. So that is a tool that is not, it can't really recover on its own, right? It doesn't really save to disk. It can't recover from a snapshot. So if that's good enough for the kind of we're talking about isolation, then that's fine. That'll work. But it may also want to consider putting it in your database, or perhaps using a separate database. So you have, your service has, like, and we're going to talk about databases here for sure, but your service has, maybe a MySQL instance, and you're storing, the source of truth for your service in there. But you may want to cache data in that database as well. So treat it as a cache. It can be blown away at any time, but a certain set of tables that you're caching data from other services. So that's really up to you. It's when I say cache, it's storing data that really is not, you're not the source of truth. Something else is the source of truth, but that source may go down for an hour or a day, and so you want to have a copy of that stored locally. So that's kind of what I was thinking there. So yeah, good question. Good question. We'll definitely get to databases later.
We had another one that was asking, how expensive is event sourcing in terms of computation and disk?
Yeah, how expensive is it in computation and disk? I mean, it can be. It depends on what you're using, I guess, to store your events, right? So if you're using a traditional relational database to store event sourcing, and if there's a lot of events, that can get very expensive, right? In terms of querying it and storing it. Disk is pretty cheap these days, so I wouldn't worry too much about the disk. The computation would be the main thing, and then performance. Then certainly RAM might come into factor there. But we'll talk about some databases later that might be good for event sourcing, especially if you're going to store the complete JSON object. A lot of CQRS patterns. You want to bubble this data up into a JSON object, like an aggregate root, so it might be better for that. But it depends on how much data you're using, how many events you expect to be logging. um, that sort of thing. So I guess the cop-out answer is it depends, right?
And that's all. We're good for
Okay,
now.
great. All right, so the next thing about being resilient, let's get back to resilient here, is respecting other services. And this kind of goes along with isolation, is that you want to prevent other services from messing you up. But in this point of view, you also want to keep yourself from messing up other services. So what do I mean by that? Let's look at one example here. So we've got a web app here, and maybe this sits in front of some other services. It's maybe it's like a service mesh or some sort of front end for various different services that are split up in the back end. So maybe service 2 goes down in this case. All right, so what this happens is a request comes in, and that request needs to use service 2. It can't, so now that thread gets locked because it's the service 2 is not responding. So the thread's just sort of hanging out there, locked until it eventually times out or gets reset or whatever, right? So other requests come in and they're not using service 2, so they're being processed just fine. They're going through and they're being handled just fine. So at this point, the only thing we have a problem with is that first thread, because service 2 is down. But you can kind of see where this is going. With enough users, enough requests, this is eventually going to lock out the entire thread pool here. We're going to have all these requests that are not using service 3 or 4. It's going to exhaust the thread pool. And so therefore, everything is now being blocked by service 2. Even though requests may be coming in that don't need service 2, if they only need service 3 and 4, they're going to be unable to get through. And so now, of course, the web app itself is on fire. So we have a problem here. So how do we deal with this? So there's lots of tactics for dealing with this. One of them may be as simple as timeouts. And I know this is .NET Group. I have some Java code examples in here, so that's okay. We're not going to go through Java code exercises today, but timeouts is the easy thing to do with this, right? So in this example here, what I've been told, I'm not a Java expert, what I've been told is that there is no default timeout here. And there's no default read timeout. Those are two different things, right? So add a timeout for the connection. After 2 seconds, okay, connection fails. Let's bail out of this thread. Read timeout, okay, well, we've connected, we're not reading yet, so let's time out for 2 seconds for that. And so, in that way, we're sort of freeing up the thread pool if, whatever service we're depending on is down. We need to respect the other requests coming into the service. There's other things, there's a whole laundry list of things you can do to better respect other services. So basically, you don't want your service to blow up because some other service is blown up. So a couple examples of this list here. So we talked about retries. A circuit breaker basically means after a certain number of failures, any more attempts to get to that service will fail immediately, again, until some timeout period. So we're kind of saying, well, we know this service is down, so let's just cut off anything that tries to use it, and then we'll check again later to see if they're back online. A bulkhead, just going to list here, is a way to kind of partition out your resources to prioritize services. So let's suppose we have a vital service that needs a user, some service that we need to, in order to close out a sale, needs a user service. And now we suppose we have another service. Maybe it's less vital. It's like an analytics, BI, a dashboard that's used internally, but it also needs a user service. The bulkhead allows you to say, okay, we're going to prioritize. The vital service, it gets 80% of the threads. And the analytics service, you get 20%, or you get 2 threads max at a time. And so that means even if analytics comes in and some clueless junior developer like I was 20 years ago comes in and writes a terrible query that goes against the user service, it's not going to blow up and shut out everybody else because we're just limited to 2 threads. So that bulkhead is a way to do that. So one of the tools you may have heard of before, this was something created by Netflix. It's kind of in maintenance mode right now, and it's kind of Java only. I think it is Java only, is Hystrix. So a lot of this stuff is built into Hystrix. But one of the problems with a tool like Hystrix, or if there's a .NET equivalent, is that it is Java only, or it is .NET only, or Node only, or whatever. So we have to build it into our program. We have to build this stuff into our code. This is kind of like a cross-cutting concern, if you're familiar with that term. We have to build in every single function, we have to build in every single application. And so it's a lot of extra work. A newer approach, another pattern, is called a service mesh pattern, is where we, instead of the microservice itself handling the network issues and the bulkheads and the circuit breakers, we have like a little service mesh kind of like sidecar there that's also, that's paired up with the microservice, but it kind of acts as a proxy. So it takes care of all the cross-cutting concerns across all the microservices. I don't have to build them into my microservice. Microservice can be mostly ignorant of that kind of stuff. The timeouts and the circuit breaker and the bulkhead can all be built into that service mesh. And it's language agnostic. So it can work with a .NET service, it can work with a Java service, a Node service. It doesn't matter because it all acts as a proxy on top of that service. So some providers here, you may have heard of some of these before. I'm not quite sure. So DAP-R is kind of a newer one from Microsoft. I don't know if that's quite considered a service mesh provider or something slightly different, but that's another something you might want to look at for microservices. But these things provide things like external configuration, so credentials and network locations, logging, so they can configure your logging framework for you, health checks, things that you can ping or plug into a monitoring tool, and again metrics to see how the application is performing. Distributed tracing. This is something that's kind of new. If you've seen the Open Tracing project, that distributed bug I mentioned early on, it's kind of a way for you to trace a individual request, an individual path through all the services, and so you can follow it along the way to see what part of that journey is taking the most time, or where did the bug come from, that sort of thing. So these mesh providers all kind of provide that, and they'll also give you some monitoring with them. So like Hystrix I mentioned is a Java framework, but let's say you're using .NET or Node or whatever, you got to use a different tool. But instead of Hystrix, you could run through a service mesh provider and get analytics on them. So this is just a screenshot from Linkerd to show you, okay, this is the traffic from your microservices. This service is peaking, it's using a lot of network. This other one is not using so much. So you can use that tool to monitor those individually and provide all those additional cross-cutting concerns there. So we've made our microservices more resilient. We've got event sourcing in there to rebuild if we need to, and to trace through some logs. We've got timeouts, circuit breakers, things like that. So we've hit 3 check marks there. We got one more to go, which is Elastic. I'm going to pause here for a second, see if any more questions have come in. And I'm going to check the chat myself.
There were a handful.
Okay.
So not in Zoom, but in Twitch.
Okay.
So I'm going to work backwards from more specific to less specific.
All right.
Let's see. Paul Chin was asking, microservice architecture, assuming, sorry, I'm trying to read text so is a microservice architecture assuming that all services will be unresponsive at some point and is trying to catch the failure before it happens?
So early on, we basically have to assume, because we're introducing network, that yes, the other services could go down or be unresponsive or not cooperate, right? Unlike a monolith where it's all together in one application. It's either all running or none of it's running. With microservice, it's distributed. So parts of it could be down for whatever reason at any given period of time. So we have to kind of act as if they could be down. And that's distributed computing, that's distributed architecture. And that's where it gets very, very challenging. That's definitely kind of the main drawback of microservices.
Someone asked if you could redefine what bulkhead meant.
Sure. So if I could redefine what bulkhead meant. So think of any given service as having a limited number of threads that it can do work with. And other services are going to make requests into that service, and that's going to cost threads. All right. So a bulkhead is a way of us giving priority to other services and saying, okay, the payment service is top priority. So it can take 80% of the threads. And that's the limit. Once it gets to 80%, we're not going to give it any more threads, for instance. And we can say the reporting service is less important, so it can take a max of 20% of the threads, for instance. So we're kind of prioritizing other services. And the reason for this is that we don't want the reporting service, for instance, to crowd out the payment service, because we'd much rather get money than worry about the reports for the CEO that are due end of business, for instance. That's a lower priority.
And then last but not least, this came in as soon as I told you before that we're done with questions. But a couple viewers were asking if you could give a more concrete example of what a microservice is. So maybe something, talk about an actual microservice, something that you might have worked on in the past, or ones that you know about out there in the real world.
Yeah. Okay. So this is something I always struggle with to define, because I mean, it means different things to different people, right? But the idea is that instead of having one process to run our program, our website, for instance, we have multiple processes. We have multiple websites that all work together. So for instance, if I come to, let me think of a relevant example here that I've worked on recently. Let's talk about, sorry.
I've always heard of Amazon as a great example of different microservices, that if you go to any product page on on Amazon, it's some of like 100 or so different microservices come together to build that product page. Right.
I mentioned Amazon earlier, and I think that's a good example. But I'm just trying to think of, if you go to like an e-commerce site like Amazon, for instance, there's all these different things you see on the page, and it kind of all seems like it's together. But if the payment system is down for Amazon, let's say, I don't know, they forgot to pay their Visa bill, I don't know, whatever, some crazy like that happened. Yeah. Their payment service is down for maybe an hour while they figure that out. The rest of the site still is working, right? So I don't have to have the payment site working, the payment part of the system working, in order to browse items, to browse the catalog, for instance, or even to place an order, or even to give you my payment information. All that stuff can be verified later with the payment system. So it's just moving different parts of the system out. And so that's one of the benefits, is that you can split out the responsibilities and distribute them so you can have higher availability. But the other benefit is scaling. So, if Amazon page gets a lot of traffic, for instance, like everyone rushes to buy toilet paper on that one page. Okay, well, we need to increase our scale for the catalog, or the catalog detail microservice. We don't necessarily need to increase scale for the comment system on Amazon, right? We don't necessarily, because people aren't blowing up a lot of comments, but they are blowing up a lot of browsing of the catalog system. So we can increase the scale for that one service. We don't have to increase scale for the payment service just yet, or the comment system, or the review system, because people aren't hitting that as hard as they're hitting the actual catalog item itself.
They're blowing up a lot of toilets. That's what they're blowing up. I think we're good on questions for now, so I'll keep an eye out.
Yeah, 100 microservices for a page does seem like a lot. I'm seeing Intergermain's comment there. That is a lot, and Amazon is very exceptional, right? So, you may not start with 100 microservices. You may start with just 2. You may start with a monolith. Okay, we'll split out the user profile portion of our site, because we realize that user profile is getting a lot more traffic recently, or a lot more usage, and it's slowing down. So we'll split out just that part so we can scale that up independently. So you don't have to think of microservices as this big, daunting, hundreds of services and queues everywhere. Just think of the very beginning as we're splitting our one web server into 2 different servers that do 2 different things. I think that's just start small, I think. Start micro. Yeah, and Paul Chin's comment. Yeah, another thing is the pizza thing, the team size thing with the pizza, I think is what I was referring to there. It's also an organizational thing. You can focus. You can have teams that are much more focused on one particular aspect of Amazon. So you don't have a team of 100 developers. You have 100 teams of 2 developers, or 10 developers, that sort of thing. Okay, so we'll get on to Elastic. Elastic, what I mean by Elastic is scaling, basically. We can scale out a service to accommodate more load. So it's not necessarily enough to just split it up into individual services, but how do we actually take those individual services and then have them scale up or scale out to accommodate more load? And so one of the patterns to deal with this, with a microservice, is service discovery and load balancing. So if you've ever done like a web farm or some sort of web servers behind a load balancer, you've seen this kind of thing before. So when you deploy a new instance, that informs a service registry that it's online. And so then when I make a request to Wikipedia, for instance, I go to a load balancer, and the load balancer says, okay, it looks like server B is up next. We'll send your request to server B, and then it will respond from server B and pass it through the load balancer back to you. And then the next request will come in and say, okay, we just sent one to server B, let's send the next one off to server C, and so on. So we're balancing out the load between those servers. And so we have to have this service registry in place. So when service D comes online, that the registry knows about it, so it can route requests to it. So that is a pattern that kind of is a little bit antiquated. I mean, if you're using it, that's fine. I'm not saying you shouldn't, but we've kind of replaced that with Kubernetes these days. So Kubernetes kind of handles all that for us. It's one of the things that Kubernetes can handle. And you get the same thing with the concept of services in Kubernetes. It's a logical set of what are called pods and a policy. So you define a service, and it's going to direct you then to one of those instances. So it's kind of that built-in like load balancer whenever you bring up a new pod as part of that service. The other thing that you can get in Kubernetes, which you may or may not want to use at first, right, is auto-scaling. So you can say, all right, we've got 3 web servers running in 3 different pods, and okay, our CPU load is now 90% of these. So hey, we need to auto scale up because our load's getting too high. So let's add another pod, and it'll do it automatically based on some of those triggers. So it may be CPU or RAM usage or something like that. So that's something you might want to look into, auto scaling. You might not want to. That might make you nervous. Could automatically add more infrastructure and automatically add more to your bill as well. So you might want to be careful about that. But it's something you can do. But what we can also do is just declaratively specify what are called replicas. So I want to scale up. All I got to do is just change this number right here. So this is a Kubernetes resource that is for Nginx, which is just a web server. And I can say replicas 2. So run 2 pods of Nginx. And if I want to make it 3, all I gotta do is change this number to 3. And then everything else is handled by Kubernetes. So if one of those pods goes down, it crashes, Kubernetes will look at this resource and say, hey, I'm supposed to have 2 replicas, but I only have 1, so I need to create another one. And it'll do that for you automatically. AWS, Azure, cloud providers can also do this kind of thing without Kubernetes, so they can do some auto scaling, but that of course is cloud specific. So it's, you're kind of locked into Azure, AWS to depend on them to do it. With Kubernetes, you can deploy to Azure AKS, to AWS EKS, GKE, DigitalOcean, whatever. It's cloud agnostic, right? Or in your own data center for that matter, if you want to use Kubernetes there. So that Kubernetes really helps with making your services more elastic, or the service locator pattern, that sort of thing. Those things can help you with your elasticity. So that's it. We've covered all 4 checkboxes. I do want to take another pause here and see if any more questions or interesting comments have come in.
Let's see. There was one asking if I have a monolith code base and I route the network in a way that distributes the load, is that an anti-pattern of microservices?
I want to dig into that more and say, what do you mean by distributing the load and
So
routing the network?
maybe it's several nodes. I'm just guessing here. So maybe several nodes and a load balance set, but
Right.
we're sending certain traffic to one node for one case or to another node for another case, but it's all the same code base.
Right. Yeah, I mean, that I wouldn't say it's an anti-pattern. I mean, that's a web farm basically. That's totally fine. But the issue with that is you have to scale the entire application, right? You can't just pick out the payment part and scale it, or pick out the user profile part and scale it. So you may be adding a lot of scale for just one part of the system, and so I mean that I wouldn't say it's an anti-pattern, but I don't think that's microservices either. So if that's the question, yeah.
And let's see. I think that was all between our last stop.
Okay.
So I think you're good to continue.
It looks like you've recommended a course here, so I'll plug that as well in the video. If you're interested in Kubernetes, check out the course by Brett Fisher. That's brettfisher.com/courses. That's BRETFISHER. Brett Fisher.
Yeah, Brett is a Docker captain and has the best-selling Docker course on Udemy right now. And he's probably one of the single most knowledgeable people on Docker, and now he's talking about Kubernetes and a load of other things. So, and his courses are super cheap. So if you want to learn it and learn it cheaply and learn it from an expert, go check out Brett.
Yep.
And I get no royalties off of this, even though I should.
You should.
He might buy me coffee. I don't know.
And just to be clear, you don't need Kubernetes to have microservices, and you don't need microservices to use Kubernetes. But they kind of, there's some things there that really are complementary. So that's why you often see them associated with each other. All right, so we've checked all these boxes. And so now we're good to go, right? Our microservices are highly scalable and bulletproof, and we're all good. Oh, we forgot one thing. What about the database? That is a big part of the system. And we haven't even, we talked about it briefly with the caching, but only as sort of an auxiliary thing. And I think this is a bold statement, but I think it's fair to say is that databases are the bottleneck of most applications. And as you're going to see here, possibly even a microservice architecture. If we could just store everything in memory, like in Memcache, all right, then everything would be blazing fast and we'd be good. But we have to store it. We have to persist it. So it's important to take databases into consideration for the performance of the entire system. So suppose we have all these autonomous services here. We have all these different, 7 different instances, different services, whatever, they're all running, but perhaps they're all talking to the same database. So, I mean, we could just scale up the database. That's one possibility. Relational databases, it's not super easy to scale them. Vertical scaling is easy, I would say in quotes, but that can be very expensive. I think I saw recently Azure just announced a new VM that's like 256 cores, something like that. And it's something like $200,000 a month, some crazy number like that. So you could scale up that vertically if you wanted to, but eventually you're going to hit a performance ceiling in terms of type of queries you want if you're storing that scale of data. And again, with microservices, you should definitely be thinking about scale as the main benefit here. I wouldn't build a blog site in microservices, for instance, unless it's a blog site like Medium. I wouldn't build crosscuttingconcerns.com in microservices. So definitely think about in terms of scale. Scaling horizontally you could also scale horizontally with relational. That can be very challenging though, because now you have to think about, well, how am I going to replicate data between the different instances and so on. So one other thing I want to focus on here is one of the benefits of microservices that we haven't really mentioned is that we've got these code bases that are split out into 4 different code bases, 4 different services, 4 different projects, let's say. So we could use the right tool for the job. We don't, and this goes back to what I was talking about with Hystrix, is we don't necessarily want to tightly couple ourselves to a single language. So maybe in our system, Python is really good for certain cases that involve natural language processing. I happen to know that it is good for those sorts of things. So we have a service that's built in Python. Our business logic, legacy business logic is in Java. So we don't necessarily want to rebuild all of that. I mean, COBOL was in the news lately. Why haven't we rebuilt everything from COBOL? COBOL is this antiquated thing. Why haven't we rebuilt it? Because it's expensive to do that. So we want to leverage that. We want to keep that Java code around. Maybe we, in an acquisition, some .NET services, some .NET code base was brought over. We want to integrate that into our system. And there's just that one team that loves JavaScript no matter what you tell them. So they're out there as well. These can all live in the same microservice system. That's totally fine. And in fact, it may even be beneficial in some cases. We can do the same thing with persistence. So maybe we store some financial data in a relational database, for instance, or Oracle, and all your Java code is fine with Oracle, so it's all there. We have another part that's storing user profiles that we want to split out, and a document database is a good fit for that because there's some flexible data needs and performance needs and certain access patterns that are better for user profiles in a document database. So I'll use Couchbase there. Another part of the system maybe is doing fraud detection, and a graph database is great for that, a really good fit for that. So we'll use Neo4j there. Another part is a search engine, like the catalog search engine. So we might want to bring in something like Solar, or even maybe, again, we want to use Couchbase here. It has its own full text search engine. So we could use the right database to accomplish the task there. And so I have a video clip here. I don't know if the sound's going to come through or not. It's not super important. But has anyone seen this before? When we used to be able to go out in public in large groups like this, does anyone recognize what this is, what's happening here? And I usually ask people to raise their hand, but this is more of a rhetorical question at this point.
6 feet.
This is a video from Central Park. There was a Vaporeon that spawned right there in Central Park. People were trying to capture that Vaporeon with Pokemon Go. And so this is kind of an older story at this point, but Pokemon Go scale went from 0 to 300 million users in a few weeks. And just try to imagine the costs of scaling during that short period of time. Massive, right? But I do want to make the point, not everyone is a Pokemon Go, right? Scaling up to that millions and millions of users, but it's not just about that, right? So if you're on Oracle right now, for instance, if you pay them enough money, I'm sure they could deliver the kind of scaling and performance that you need, but it's going to, it could cost a fortune. For that certain use cases, that may be a problem. A NoSQL database may cost less in terms of licensing, but also in terms of how they scale. You don't necessarily have to have that massive 256 core machine. You could have just a bunch of lower end machines all working together as distributed. So with polyglot databases, it's about using the right database. We could, if we really wanted to, use a relational database to work with graphs to do our fraud detection. But chances are a graph database is going to do it way, way better. So there's other trade-offs there. In terms of cost, in terms of use case, in terms of which tool is the right tool for the job. And of course, this is my obligatory plug for Couchbase. It's something I would consider looking into if you are looking for a good document database. I would say replacement for relational, not in the sense that I would say drop your relational database and use Couchbase. But if you have not used NoSQL before, Couchbase is going to be a good place for you to start. A document database in general, certainly, Couchbase especially, because you can write SQL queries in Couchbase. And it's also great for the caching we talked about earlier, because it has a memory-first architecture. It's actually kind of a descendant or a distant cousin of Memcache, someone brought up earlier. So as you start to move towards microservices and slice up your monolith, you may want to try Couchbase with one of those microservices. So it's easy to scale. It's a distributed database. I find it to be easy to scale, but how do we make it elastic? How do we plug it into that Kubernetes framework that I was talking about? So what I want to talk about now briefly is the Kubernetes operators and how they correspond to databases. And this is an important part of of Elastic. So an operator in Kubernetes is an application-specific controller that extends the Kubernetes API. And the main reason you do this is to manage instances of a stateful application, which is more complex than an application without state, that if it goes down, no big deal, we'll just bring up another instance of it, keep going from there. So for operators, you could have, for instance, a Couchbase operator, a MySQL operator, etc., that will give you some Kubernetes, extend Kubernetes to allow you to do more specific things for those databases. You don't, strictly speaking, need an operator to run a database in Kubernetes, but if an operator is available, I think you almost should definitely use it. It's going to save you so many headaches having to write scripts or do manual tasks to manage and maintain that database, especially a clustered distributed database like Couchbase. So this is a Kubernetes resource here. It's using the Couchbase operator, and it's defining a Couchbase cluster. And so notice here that there's a size of 2. So just like we saw with the Nginx example earlier, all we have to do is just change this number to a 3, and we can scale it out. And that's the simplest possible thing we can do with Couchbase to scale. There's other things we can do to move the services around and have more complex scaling depending on our use case. But the simplest form, we can just say, okay, I have 2 nodes of Couchbase in my cluster. Let's make it 3. Without an operator, I'd have to, at very least, do some scripting or manual steps once I stand up another pod, I have to then connect that pod to the other pods, and I have to make sure they all know about each other. And what happens if one of those pods goes down? Do I automatically run a script? All those kinds of things. Well, the operator does that stuff for us. This is, I don't know why this is in here, but this is the actual YAML file for the operator itself. There's nothing really to point out interest there. Oh, I guess that currently the operator is 1.2, although I think we just announced a 2.0 beta of the operator with some more functionality in there. So this is kind of things you get from an operator. This is the Couchbase one specifically, but other operators will provide similar capabilities. So it has things like logging built in, automatic recovery, which is especially important for a distributed database, scalability, I mentioned the elastic scalability, backups, so automated backups included in the operator. So this is all things that you're declaratively saying, give me Kubernetes, do these things for me, instead of I'm writing a script to check, do I need to do these things, write a bunch of logic, things like that. So, but again, you could use the APIs of your database to do this stuff yourself. You could use Couchbase APIs to manage all this stuff yourself. And behind the scenes, that's what the operator is doing. It's using Couchbase APIs. But unless you have a really good reason to do that stuff, I'd stick to an operator if there is one. So I want to have a quick demo of some Kubernetes stuff if we have time for that, if that's okay. If you all want to see that. I also want to take a second to stop for some questions.
Let's see. Paul was asking on Twitch, can Couchbase do Redis type things for caching?
Yes, I'd say Couchbase can do Redis type things. So Redis is like a memory intensive database caching sort of thing. Couchbase is memory first. It also has memory only options. So if you want to just store data in memory, like I was mentioning earlier, you can do that with Couchbase too. But by default, kind of the Couchbase behavior is memory first and then store things to disk. So we can recover from that very quickly. And it in real time stores it to disk. So it's closer to a traditional database, where Redis I would consider more of like, maybe you could ask Guy Royce about this. He might say I'm wrong, but I think of it more as a caching tool.
We don't need to get Guy Royce involved in this discussion. Demetrius had a question in Zoom, but I'm not quite sure I'm not quite sure what he's asking. So
let's have a look.
Yeah.
So an operator is like a cross-cutting plugin. I guess you could think of it like that. I think of it more as, it's just like, Kubernetes API is kind of generic. It allows you to do a lot of things. but it doesn't allow you to do anything specific to Couchbase or specific to MySQL or specific to SQL Server. And so this is kind of a way to extend the Kubernetes API to give you a more specific API that you can handle. So let me just go back a slide here, give you an example. So here in the Couchbase YAML file here, there's this bucket section here. I don't know if I can illustrate this or not, but this bucket section here. So that's saying I want a Couchbase bucket, which is a collection of documents called Hello Microservice. That's something I can only do with the Couchbase operator. Kubernetes does not know anything about Couchbase's internals, what a bucket is in Couchbase terms. It doesn't know what a table is in MySQL, things like that. So the operator gives me the ability to communicate those things specifically to Couchbase. Operator is like a human operator. Yeah, you can think of it like that. It's a declarative way of defining things through the Kubernetes API, but for more specific pieces of software. Generally, it's databases. It can be other things like Kafka, for instance. Anything that maintains state, an operator is really good for. Was there any more?
No, I think we're good for now.
I really do want to get to this demo because I set up an AKS cluster today and everything for this. So,
well, go for it.
Okay, so this won't take too long, I don't think. But I have a AKS cluster set up here on Azure. The AKS is the Azure Kubernetes service, and so you can see here I just get pods, see what I have running. I have the operator for Couchbase running, and some of the role-based security stuff for that. I've got 2 nodes of Couchbase. So Couchbase is a distributed database. There's multiple nodes that all work together as a cluster. So it itself is a distributed system within a distributed system. And then I've got this Spring Boot. So Spring is a Java framework. Not really important for this presentation, but it's a web server running there in Spring Boot. Okay. So if I open up kubectl port forward, and I want to connect to one of these Couchbase nodes. Oh, I gotta specify ports. So I'm just sort of tunneling into my Kubernetes, cluster into my local PC. So this is a Couchbase cluster running on. And I'm okay showing you my lousy credentials because you can't get to this server. But this shows my 2 servers of Couchbase here running on Kubernetes. And you can see here they're running on AKS and Kubernetes. And I can do a similar thing with my Spring service. So I'm going to port forward to this. kubectl port forward this, and that's 8080, I think is the port number for that. Okay, so what that service is doing is it's in the background, it's going to be creating data and putting it into Couchbase. So it's been running this whole time, all day, in fact. So you can see it's got 16,000 items in there, and it's going to keep going up. It's going to keep adding items in the background. 16,720 and so on, right? You see the items number increasing there. And it can also just access, I have like a really simple REST API for this site out here. I can get a list of users. Hopefully. And so that's the Spring service running there. It's using Couchbase as the database, and that's all running inside a Kubernetes cluster. As you can see here. So I've got those pods there. Now let me open up my Kubernetes YAML files here. These are how you define services, resources in Kubernetes. And so I have a, where is it? Kubernetes Couchbase cluster right here. And you can see I've said, give me a cluster of size 2. I'm going to change that to size 3. So I've changed that YAML file. Now I just say kubectl replace -f Couchbase cluster. Okay. And so now I've just uploaded that YAML file. There's other ways to do this, but this is a really simple demo. So now if I go get pods, you can see, well, right now it hasn't quite started on it yet, but there will be a CB example 0002 that shows up here eventually. There it is. So it's in process of adding a 3rd node to the Couchbase cluster. Why would we add a 3rd node? Again, for elastic purposes, we want to handle more traffic, more more data, more RAM, things like that. So you can see it's not quite ready yet. But if we go back over here, you can see that the operator is doing the work for me. I don't have to do anything manually. Normally I would in Couchbase say, okay, add a node here and configure it. The operator is doing all that work for me. He's doing the rebalancing, all this kind of stuff. So you can see there's a third server in my cluster now. And it's starting to rebalance the data around. I'm not going to go into Couchbase internals too much, but it's doing that for me. I could do a similar thing with my Spring Boot app. Right here, replicas. It's only one right now. It's only one pod. If I change that to 2 or 3, it's going to add 3 total nodes. Now at that point, I need to define a Kubernetes service with load balancing. I'm not going to do that today. That's maybe a bit much, but you can see that it's a really simple matter of just changing a number and away we go. One other thing I like to point out is Visual Studio was screaming at me today with all these yellow squiggles because I did not put any resource limits on this. This is another way for me to respect other services. If you don't limit the resources on like Spring Boot, for instance, it could potentially eat all your memory in your cluster, eat all your CPU. So we want to restrict that. We want to limit the amount that I think the whole service will use, right? Up to, in this case, a gig of RAM and you know, 500 million operations or whatever this is for resources. So that's another way. I just wanted to demonstrate that. Fortunately, Visual Studio Code caught that for me and said, hey, you probably want to put a resource limit on this. Okay, so let me just see how long this is going to take. Yeah, it's still in process. So it does take some time for that rebalance to actually happen. You can see it's in process right here, 70% done. The cluster is still available during that time. It's just that it's doing some processing in the background to even things out in the database. But all that stuff's being handled for us by that operator. So we've got the ability to handle the elastic needs of our microservice. I think that's all I want to show with the demo.
Question. So
Sure.
you moved up to three services. What if you scaled it back down to 2? What happens to your data?
Yeah, I usually would do that in this demo. I don't know if we have enough time for it. Scale back down. What would happen is, well, first of all, I asked why would you want to do that? And the reason may be, okay, Black Friday is over, retail, peak retail is over. Let's scale back down to save some money, right? That might be a good reason to do that. I would say with Couchbase, the recommendation is go down one server at a time so you don't lose any data. Because Couchbase is distributed, so there's replication in place. If you try to bite off too much and scale down at a time, you may lose some data in the process. So one at a time, and you won't lose any data when you're scaling down. When you're scaling up, you can scale up as much as you want to. You can change this to 15. Now, my AKS cluster can't handle that, so I need to think about scaling my AKS cluster as well. That's a whole different matter.
Is
Good
this,
question,
there's a follow-up question. Is the like a replica or is it sharding?
It's doing both. Couchbase does both of those things automatically. So if you look here, I think we're done actually. So it's done doing the rebalancing, but look at this items over here. You can see the first number is the total items, and the second is the number of replicas that's stored on that individual server. So Couchbase does automatic sharding. So there are, and you saw this earlier on the screen, but well, you can't see it now. But there's a concept called VBuckets in Couchbase. We're really getting into the weeds here. I've got a Pluralsight course coming out that covers this stuff soon, but it does automatic sharding. So anytime you write data to this, it will assign it to one of 1,024 VBuckets. Those 1,024 VBuckets are split up evenly amongst all the nodes, so that's automatic sharding. Replication is also automatic. You can see each node stores replicas as well. So in this case, my Couchbase sample bucket, I'm saying give me 2 replicas of each piece of data. So it handles that automatically. This may be, the question may be because other databases, it's more complicated. You have to set up sharding, define what sharding means, you have to set up replication. With Couchbase, that stuff's all built in. It's all automatic, it's all handled for you. So thank you for allowing me to plug Couchbase for that question. I think that's all I want to show with the demo. I could take us back down actually, if you want to see me drop down to 2 services again, just to see what would happen. I made one change to a YAML file and replaced the YAML file. And now if we go back to Couchbase, eventually this will turn red and start to go away. Well, sorry, it's not going to turn red because this is not a, it's not a failing event. This is just we're sizing it back down. So the operator's handling this. We're rebalancing the data. It'll eventually decommission this third machine. And what will eventually happen is CB example 002, or maybe one of the other ones for all I know, 00 or 01 might go away. One of those three is going to go away for sure. Let me scale down. We've done all this by just changing a number in a YAML file. Very declarative, hands-off approach to handling elasticity. So that's one of the benefits of Kubernetes. Okay, I think that's all I wanted to demo. So I'm going to go back to slides now. Happy to go back if anyone has any more questions or wants to see me try something. But I do want to cover a few other things here first. So just wrapping up here, there are lots of operators out there. This is a screenshot I took just last week of operators. So if you go to operatorhub.io, you'll see it's a lot of database stuff, but there's other operators out there as well. Some of them are like official, like the Couchbase one is official. Some of them are community driven. Generally speaking, it's been my experience that the official ones generally work with the enterprise editions of these databases. So like the operator only works with the Couchbase Enterprise, the Mongo only works with Mongo Enterprise, not the free versions. But you know, again, we're talking about large scale companies, large enterprises, and they're probably on the enterprise version anyway. But some of them are like a community, support community versions as well. And again, you don't have to use an operator to use a database in Kubernetes, but it does help. Next steps for you. If you want to learn more about Couchbase, go to couchbase.com/downloads. We just released the 6.5 community edition, the totally free version of Couchbase. Free training. You can learn more about the operator specifically if you want to go to that URL right there. We have a blog. That's a link to just blogs about Kubernetes on Couchbase. And if you have technical questions, you can ask in the forums. I also wrote a couple of blog posts about getting started with ASP.NET Core microservices, starting with Docker Compose locally, and then moving towards deploying to a full Kubernetes cluster in production. So you can start there, go to that bit.ly address to go to that blog post specifically. And I would also consider myself a resource for you. So if we're in person, I would say let's hang out afterwards. Let's talk about your questions or feedback. I'm happy to do that here too. You can also contact me on Twitter. That's my email address. You can contact me there. I do live coding on Twitch. You can absolutely. I've done a lot of the stuff that I'm presenting here on Twitch streams in the past. So there's videos, but I'm always happy to go over it again live if you're interested. So you can always come by and chat and have fun, hang out on the Twitch channel there. That's it. Before I stop for last wrap up of questions, I want to say in these stressful times that you all have, taken time that you could be spending, making important trips to Home Depot or, just taking care of your loved ones and all those sorts of things. And you've chosen to spend a little bit of that time with me and the HR NUG group tonight. So really appreciate that. Thank you all for hanging out. Thank you for such great questions. And do we have any more questions that you want to talk about?
Let's see. Just applause. Everyone's applauding.
Oh, that's great. Thank you. I think a cheer would be appropriate. So let's all spend our bits to cheer.
Yes, everyone spend bits.
Channel. There we go.
Buy me coffee. That buys me like a little bit of sugar in my coffee, I guess.
Let's see. Any questions?
Very nice.
Any patterns used for microservices to front end, like an API gateway? Yeah, this is an area I haven't spent too much time in, but I think if you want to expose multiple microservices to a front end, kind of the anti-pattern is to have to connect to each of those services individually, right? And that's just going to be a headache to manage that. So you might want to put some sort of facade. I guess API gateway. Sometimes it's called that, or sometimes it's called like a a service mesh on top of those. There are some, a colleague of mine, Eric Bouchard, who's a HTTP junkie on Twitter. There's also ways you can kind of aggregate REST services or other types of services behind like a GraphQL interface that kind of unifies them to a GraphQL query. So that might be another approach you want to take there.
Let's see, Paul had a question. A service mesh is just a network router, really, right?
Yeah, I guess you could think of it like that. It's not just a network router. I mean, there's other features, like I said, you can build in some logic to it, some monitoring, things like that. But basically, you can think of it like that, right? It sits on top of the network, acts as a proxy, and provides those cross-cutting concerns. Everyone's found the highlight button, or Integer Man's found the highlight button.
Don't spin those points. I don't get anything for those points. Spin bits. It's all right. Or sub. I mean,
yeah, hit the subscribe button.
Yeah.
If you're a
follow
Prime member, you get one for free.
I've been sitting here at 199 followers for the past half an hour, and I'm like one more, I'm at 200. So
I wish I could be your 200th follow, but I'm already following you.
I know. I posted your channel in the Slack. So.
Oh, thank you. There you go.
Oh, Jonathan. Jonathan subscribed again for 8 months.
Oh, another one.
Good job.
They're coming in like crazy.
He's my only biggest fan. I love Jonathan. Blue Speed Gamer, thanks for the subscribe.
Cool.
You're very welcome.
Oh, wait. I had a follow. I had 2 follows. So
Ooh.
Quinn was my 200th follower. So yay, Quinn. And then S Googs followed after that. So thanks for the follow. I appreciate you all so much. All right. Well, I'm going to stop the recording, but we'll hang out for a couple of minutes if anyone wants to chat or ask Matthew any more questions. But Matthew, thanks for hanging out with us for HamptonRoads.net this month, and we'll be virtual again next month. And I don't know what we're going to talk about. We'll figure that out. If you'd like to speak to our user group, ping me privately, either on Twitch or on Twitter at @1KevGriff, and we'll get you signed up. We'd love to have you. But until then, well, everyone hang around and chat with Matthew as much as you want to. You don't have to go home. You can stay here. That's fine.